Alright, welcome back. I didn't end the last video, sorry, and please do well to subscribe to Massa Tutorials and get more of my mathematics videos. Alright, so let's go. Equation of a perpendicular line. How do we find for the equation of a perpendicular line? So the equation of a line which passes through the points x1, y1 and perpendicular towards another line. I told you that in perpendicular lines, that's perpendicular means 90 degrees. So that means if a line is perpendicular to another line, then that means their product of their gradient must be equal to what? -1. Right? So it means that m1 times m2 must be equal to -1. Right? So here we can make either m2 or m1 the subject by dividing here by m1, here also by m1. So I get m2 being equal to what? -1 on what? M1. We can make any the subject, right? So now let's see. Kindly listen, right? So now two lines are said to be perpendicular if the product of their gradient is what? -1. Two lines are said to be perpendicular if the product of their gradient is -1. As I said, that is if the gradient of a line is m and the gradient of the line perpendicular to it is what? -1 on m, as we did here. So the equation of the straight line perpendicular to another line of gradient m passing through the points x1, y1 is found by making y the subject. Of the formula y minus y1. So by making y the subject, y minus y1 equals -1 on m, then x minus what? x1. So it means that if a line is perpendicular to another line, then that means you have to find for the other gradient. You not put the same gradient into for finding for the equation of the line. You will not put the same gradient. When you put the same gradient, then you mean that they are what? Parallel, which is wrong. But this time around, we are talking of what? Perpendicular. That's 90 degrees, right? Perpendicular lines, right? Perpendicular lines. Which means that when they give you the gradient to be 3, the reciprocal, then you negate that. When you finish finding for the reciprocal of 3, then you negate that. So 3, the reciprocal of 3 will get what? 1 on 3. So when you negate that, you get -1 on 3. So that will be the gradient of the other line. Are you getting that? Alright, so the gradient of the other line is this. Then you place it inside, then use your points on that same line, then you find for the equation of that line. Very, very simple. Very, very simple. So now let's try an example. Let's try an example here. Let's try an example here. It says what? Find the equation of the line. Find the equation of the line. Find the equation of the line. Perpendicular, which is 90 degrees. That's the symbol for perpendicular. Perpendicular to the line. Perpendicular to the line. 5x minus 2y. 5x minus 2y minus 11 equals 0. Which passes through the point. Which passes through the point. Which passes through the point to -3. So solution here. How best can we solve that? So watch the question very well. So how best can we solve this question here? Find the equation of the line perpendicular to the line. So that line, the supposed line we are finding, is perpendicular to this, right? So see something here? It's perpendicular to that, right? So the supposed line. So it means that this is the supposed line we are finding, and that is what? Perpendicular to this line, right? So this line, that's L2, which is what? 5x minus 2y minus 11 equals 0. That's the equation of that line. and this one is the line, the supposed line we are finding. So let's label it what? L1, which is what? AX plus BY plus C, which is equal to 0. So it is perpendicular to line L2, right? So now, how best can we solve that? How best can we solve this question? So now, they've given you what? Which passes through the point, 2, -3. So they've given you the equation, the point, this line, it passes through this point. So we can say that let M be equal to 2, -3. So this line passes through that point M, 2, -3. So how best can we solve that? Now, since this line is perpendicular to this line, since this line is perpendicular to that line here, how can we find for that? So now we have to make y the subject in order to get our gradient. So let's make y the subject. So I have -2y equals what? -5x, then plus what? 11, right? We group like terms, we send this to the right hand side and that to the right hand side. Then I divide here by -2, -2. Then I get my y being equal to 5 on 2x, then -11 on 2. Because positive and negative, when they meet, negative is formed, right? So y equals what? 5 on 2x minus 11 on 2. So we can say that M1 here, this guy, the gradient for line L2 is what? 5 on 2. That's the gradient for line L2. Now, how can we find for the gradient for this L1? Now, you cannot say that they are the same. No, we are not talking of parallel lines here. We are talking of perpendicular. So it means that we have to use what? It means that we have to use M1 times M2, which is equal to -1, right? Or you just take 5 on 2, just take the reciprocal. 5 on 2, the reciprocal of 5 on 2 is what? 2 on what? 5, right? Then you attach your negative. So that means M2 will be equal to what? -2 on 5. Alright, so let's proceed. So M2 is equal to -2 on 5. So we can use this. So we are supposed to use this guy, -2 on 5, into our formula, not that. Because this is the gradient. This is the gradient for this line. So which is M equals to -2 on 5. Then we use the point, which is 2, -3. So now let's see, which is y minus y1 equals m x minus x1. So now our y, we don't put any value inside, minus y1. So x1, y1, our y1 is -3 equals m, which is what? -2 on 5. Then x minus x1, which is 2. So I have y plus 3. Because negative, we get positive, equals -2 on 5x, then plus what? 4 on the area, 5, right? So now, we can group like terms. So I have y being equal to, I send this positive 3 to the right hand side. So I get -2 on 5x, then plus 4 on 5 minus 3. So I get my y being equal to -2 on 5x. Then 5, 3, 15. So I get 15 minus what? So I get 4 minus 15, 4 minus 15 on what? 5. So now we have what? Y being equal to -2 on 5x. Then minus, because 4 minus 15, we get -11 on what? 5. -11 on 5. So this one is the what? Is the equation of the line. That's the equation of the line, which is what? Perpendicular to this line, what? L2, which is perpendicular to this line, L2. So kindly mind you, when you are solving this type of questions, mind you, don't substitute this gradient into the equation of that line you are finding. No, you get it all wrong, because you are finding for parallel. And the question here, it says, is what? Perpendicular. Because it's perpendicular, their product, the product of their gradient must be equal to -1. So when you get the gradient, which is 5 on 2, just take the reciprocal When you take the reciprocal, you get 2 on 5. Then you attach negative to it. So that means you get negative 2 on 5. So the reciprocal of the gradient attaching negative to it, that will be the gradient of this line, L1. Then you use the line which passes through this point M and the gradient negative 2 on 5 to find for the equation of that line L1, the supposed line. Very, very simple. So kindly watch it carefully. Alright, so let's see our last example. Our last example then. Very, very simple. So when a question comes in this nature, kindly take note of that question. Very, very simple. Very, very simple. So let's see. Let's see a question here. Let's see a question here. It says, still given the line L with equation ax plus by plus c equal to 0, and the point P x1 y1. It says show that. He said we should show that the line through P, perpendicular, that's the symbol for perpendicular, to L is given by bx minus ay, which must be equal to b x1 minus ay1. So now let's see whether there is no typo inside, right? So let's solve this question. So we are using the same analogy here, the same idea to transform this question to what we want. So given the line L with equation ax plus by plus c equals 0 and point P x1 y1 shows that the line through P perpendicular to L is given by bx minus ay equals bx1 minus ay1. So now we have our equation, which is what? Ax plus by plus c equals what? 0. Perpendicular, don't forget, the product of their gradient must be equal to -1. So now we want to express this in the form what? Y equals mx plus c. Then we get our gradient. Then we take the reciprocal. Then we negate that. Alright, so now I have by being equal to, I send negative ax, then negative c, right? Send positive ax to the right hand side, so I get negative ax. Then positive c to the right hand side, I also get your negative c. Then by, I divide both sides by b. So negative ax on what? B minus c on what? B. So I get y being equal to negative a on bx minus c on what? B. Sorry. Alright, so let's continue. So I have my m, which is negative a on what? B. Right, so that's m1. Now we want m2 in order to use it to find for the other equation of the line. So now, since I want m2, now m2, watch here. There is a negative here already. Do you understand that? The other one, they didn't give us any negative there. That's why we took what? The reciprocal of that. Then we attached what? Negative to it. But here, there is a negative here already. So just take the reciprocal. Then here, you don't attach any negative to it. So you take the reciprocal, which is b on a. That'd be all. So it means that when you multiply this guy by that guy, you have to get -1. Let's see. Negative a on b times b on a. This one cancels, which is -1. As simple as that. Please, if you want more understanding, kindly visit our, I think, last tutorials here. You get that's relationship between the gradient and the perpendicular lines. You get that. You get more understanding from that place. So now here we are using this gradient and the point. What's the point here? P x1 y1. So I have my equation of the line y minus y1 equals m x minus x1. That's the formula, right? So I have y, you don't put any value inside, then y1 is still y1 equals m, which is what? B on a, then x minus what? X1, because our x1 is still x1. Then what do? We multiply through by a. So I get my ay minus ay1 equals b times x minus what? X1. Right, so now I can multiply through by what? B. So ay minus ay1 equals bx minus what? Bx1. So now, let's see. They said we should let it be what? The same thing as that. Bx minus ay. So bx minus ay. So let's see bx. So bx. So still we have our bx minus ay. So this guy crosses. This guy crosses. Still, I've not used this guy to cross. So I'm just writing it first. So bx is still at the right hand side. So bx. Then this guy is positive. When it crosses, I'll get negative ay. Right. Then what again? B equal to bx1. Bx1. So then that means it has to what? It has to cross. Right. It has to cross. So now, when it crosses to the left hand side, I get bx1. Right. Then I have my minus ay1. So minus ay1. Minus ay1. So as simple as that. As simple as that. Very, very simple. Very, very simple. Very, very simple. So as you can see, it's very, very simple. Can you watch it carefully? Or still, if you don't understand, then you can, if it is confusing you, you can send this to the left hand side. So I'll get negative bx, then plus bx1 equals, this one goes, I'll get ay1, then minus ay. Right. Then what do? Here is positive, negative. So let's divide through by negative 1. So negative 1, negative 1, negative 1, negative 1. So this one cancels. So I get my bx, which is the same thing. Then let's see our ay. Here is minus bx1 equals minus ay1, then plus what? Ay. Right. So now we want it to be like this. So my bx is still there. My bx, this one counts. I'll get minus ay equals, this one is minus ay1, which is this. So I send this one to the right hand side, which is that. So bx1 minus ay1 as required. So when you are done, because it says show that. So if it is possible that they are equal, so that's it. That's it. That's cool. So kindly watch it carefully. Very, very simple. Alright, so I'll end my tutorial here on equation of a perpendicular line. Equation of a perpendicular line. So kindly watch it very carefully. It's very, very simple. Just follow the steps, then you move. Thank you very much. Have a nice day. Bye-bye.